All right, so let's go ahead and develop our understanding of predicate logic a little further by showing how we can use more than one quantifier and more than one variable to capture English sentences that are richer and more interesting. So there's really no upper limit on the number of quantifiers and variables that can be incorporated into a predicate logic proposition. So something like this is a perfectly well-formed formula in predicate logic. It has three quantifiers, two universal, one existential, and therefore three variables, x, y, and z. Not at all clear what something like this would mean right now, but it is a perfectly well-formed formula. So let's go ahead and see if we can understand how multiple quantifiers work. Take a look at a sentence like this: something loves something. Now, how would we represent a sentence like that? Well, if you were only using one quantifier, you might say something like this: there exists an x such that Lxx. But the problem there is that this actually means there exists an x such that it loves itself. X has to be the same thing in each case. So this means something loves itself. Now, alternatively, you might say, again, a perfectly well-formed formula, there exists an x such that Lxa. But that actually involves a specific name, say A for maybe Alina, and that just says there is something that loves Alina. And we don't want to be that specific, right? So we want to say something loves something. So how do we do that? Well, the answer is that we need to introduce another quantifier and another variable. So something loves something would be written as there exists an x and there exists a y such that Lxy. And that's exactly how you read that. There exists an x and there exists a y such that Lxy. There exists an x and there exists a y, and x loves y. Okay? So it's important to understand that the meaning of this sentence does not actually imply that x and y have to be different. So if Alina loves Alina, okay, if something loves itself, in other words, then there would be an x and a y such that x loves y. It's just that it would be, x and y would be identical. They'd be the same thing. So when we introduce two distinct variables, that doesn't mean there are necessarily two distinct objects. It just allows for that possibility. Okay, well, how are we going to say everything loves everything? I bet you can do this. You're going to use the other quantifier, right? So everything loves everything would just be for all x, and for all y, x loves y. For all x and for all y, x loves y. Well, how about something loves everything? Go ahead and try that one. So hopefully you see that you're going to use the existential and the universal here. So how would you write something loves everything? Okay, so the answer here is going to be there exists an x such that for all y, Lxy. Okay, there exists an x, there is at least one thing, such that for everything, x loves y. So there's something that loves everything. Now, what you probably ought to be wondering here is, does the order of the quantifiers really matter? Couldn't I have switched the universal with the existential and said the same thing? Well, what if we had translated that sentence, something loves everything, as instead of there exists an x such that for all y, X loves Y, that for all Y there exists an X such that X loves Y. So this one. So we've reversed the order of the quantifiers here. Now think about what that means. Say it, right? For all Y, there exists an X such that X loves Y. Okay? Now what that actually means is not that something loves everything, like some one thing loves everything, but rather that everything is loved by one thing or another. Okay, so that's a very different statement. It's one thing to say that there is one thing that loves everything, something loves everything. And it's another thing to say that everything in the world has something that loves it, right? So it's actually quite cool to see that these, just by switching the order of the quantifiers, we express a very different proposition. So predicate logic is very precise. In some ways, it's even more precise than the English sentences that it's representing. So this might all be pretty clear to you, but let's go ahead and just be explicit. So reconsider our three-object universe, a universe that has only three objects, say A, B, and C. Now, if something loves everything, if the proposition something loves everything is true in this world, then at least one of the objects, say A or B or C, loves every other object, including itself. So this proposition, something loves everything, would be true, would be made true by a statement like this. A loves A, and A loves B, and A loves C. That's only one way for it to be true, but that would make that statement true. Something loves everything, and this would be A in this case, because A loves itself, A loves B, and A loves C. But everything is loved by something. Everything is loved by one thing or another. Doesn't mean that everything is loved by the same something, right? It just has to be the case that everything has at least one thing that loves it. So, for example, this statement, this proposition is true if, for example, A loves A and A loves B, and then B loves C, because now everything is loved by something. It just so happens that A loves itself and A loves B, and then C is loved by B. Turns out C doesn't love anything at all, but that's fine to make that statement true. Okay? So how about everything loves something or other? How would you write that? Go ahead and try that. Everything loves something or other. Okay, so this is represented as for all x, there exists a y such that x loves y. Everything loves something or other means that for everything there is something such that it loves that thing. So for all x, there is some y such that x loves y. So this doesn't mean that everything loves the same thing, right? It just means there's something that everything loves. So finally, let's do this one. Everything loves some one thing. Everything loves some one thing. Go ahead and try that. To do this one correctly, it might be easier to think of it as saying some one thing is loved by everything. Okay, so in this one, the order of the quantifiers doesn't quite reflect the order of the pronouns in English. So when we say everything loves some one thing, it makes it sound like the universal quantifier is going to come first. But actually, what we want to say here is there exists an x such that for all y, y loves x. So there is something such that everything loves it. Everything loves some one thing. there exists an x such that for all y, y loves x. So this does mean that everything loves the very same thing. So here's a table showing what we've learned so far. And it's really it's worth just appreciating just how precise this is, but also try to make sure that you can reproduce each one of these on your own. The other thing that we can now do is we can insert negations to capture other English sentences. So something does not love something. Okay. There exists an x and there exists a y such that it's not the case that x loves y. Nothing loves anything. For all x and for all y, it's not the case that x loves y. Everything is unloved by something or other. Well, for all x, there exists some y. For all x, there's something such that y doesn't love x. Some one thing is unloved by everything. Well, there exists something such that for everything, there exists an x such that for all y, it's not the case that x loves y. Okay, so negations aren't particularly tricky. They can be inserted anywhere. A negation can be inserted in the front of any quantifier. So, for example, a formula like this. There exists an x such that it's not the case that for all y, x loves y is also a well-formed formula. And when we write predicate logic formulas, it turns out, and we'll be able to make this clearer later, that we can create logically equivalent formulas just by changing the quantifier and redistributing the negation. So for all x, there exists a y such that not lxy is actually logically equivalent to for all x, it's not the case that for all y, lxy. So what's happened here? Well, for all x is the same, right? But what's happened is that this quantifier has been changed to this one, and the negation has been moved over, right? So this, again, is very reminiscent of the De Morgan's relationship. And as I explained the last lecture, it actually is, in a certain sense, the De Morgan's relationship. This is something we'll explore later on. All right, so moving forward, how would we say something like this? How do we say Melvin loves cheese? Now remember, very important to remember that it's not this, right? Loves Melvin cheese. It's not that, because cheese is not a name. Cheese is a property, right? So we say Melvin loves cheese like this. For all x, if x is cheese, then Melvin loves x, interpreting Melvin loves cheese to mean Melvin loves all cheese. So we know how to do that already. How do we say then everyone loves cheese? Everyone loves cheese, not just Melvin, but everyone. Well, what we're going to do is just translate everyone, first of all, as everything. Okay, that's the simplifying assumption we'll make here. Everyone often means every person, but we'll just translate it as meaning everything. So how would we do that? It's going to have a similar structure, but we're going to introduce another quantifier, just as we've been doing before. So everyone loves cheese will be stated in this way. For all x and for all y, if x is cheese, then y loves x. Okay, so we've just inserted a quantifier and another variable in the place of Melvin. So everyone loves cheese could also have been written in this way, and this is actually a little bit more intuitive. For all x, if x is cheese, then for all y, y loves x. For all x, if x is cheese, then for all y, y loves x. This is a perfectly well-formed formula in predicate logic 2, and it means exactly the same thing. What we've done here is just put the quantifiers in a different place, and we can create the original formula, our original translation, by just taking this quantifier and moving it right here, right in front of in front of the first quantifier, but with outside the parentheses. Okay. So we haven't defined the rules yet for making woofs. We're going to do that in the next lecture. But we can observe that in this formula, there are no unbound variables, right? The x here, by being on the outside of the parentheses, is still binding this x as well as this x. There's no y over here to worry about. So this quantifier is still applying to, is still binding the only y in the formula. This wouldn't be a woof though, right? Look at this. For all x, cx. If for all x, cx, then for all y, lyx. Can you see what's wrong with it? So x for all x binds this, but because there's no parentheses, it's not binding this x anymore over here. So this is what we would call a free variable or an unbound variable, and that's not permitted in predicate logic. Okay, so let's go through some of these statements or propositions a little more quickly. Everyone loves cheese, which we've done. Everyone, I'm just writing it a little more explicitly as everyone loves all cheese. Could be either of these two. We already did that one. How would we do someone loves some cheese? Someone loves some cheese. Well, here we're going to use existential quantifiers, and it can be, again, we can distribute the quantifiers either way. So I'll just focus on the second way because I think this is more intuitive. There exists an x such that x is cheese, and there exists a y such that y loves x, right? So someone loves some cheese. Now this, strictly speaking, this says something loves some cheese, but we're interpreting someone as something. There is a cheese that everyone loves. How would we say that? There is a cheese that everyone loves. Go ahead and try that one. So this is going to involve a mixture, an existential and a universal, right? So we're going to have, there exists an x such that x is cheese, and for all y, y loves x. There is something that's cheese, and everything loves it. Someone loves all cheese. Give that one a try. Someone loves all cheese. There is someone. There exists an x such that for all y, if y is cheese, then x loves y, right? Someone loves all cheese. There is someone such that for all y, if y is cheese, then x loves y. So you'll notice here that we preserved the x coming first and the y coming second in the quantifiers, but the variables within the parentheses got switched around. It could have been done either way. Now, is there anything that goes over here? Actually, the answer to that is no, because what would happen, like what if we redistributed the universal quantifier so that it was inside, right? So suppose we wrote, there exists an x, parentheses, such that for all y, cy, then Lx, y. Would that be okay? Well, notice that the existential is picking up this x variable, which is fine, but now we've got this universal applying to the y here, but not the y over here, right? So actually, there is nothing that goes in this column in this case. The first one we wrote is the only proposition that works. Okay, everyone loves some cheese or other. Everyone loves some cheese or other. How would we write that? So for all x, there exists a y such that y is cheese and x loves y. Now again, for the same reasons, there's nothing in this column, right? Because if we move the existential in front of the c, again, this y would be an unbound variable. But notice again how important it is that we use the and in this case. Okay, it's not an arrow. This says everyone loves some cheese or other. So you can't infer from the fact that something's cheese that it's loved by someone. This just tells us that everyone loves some cheese, but not all cheese is loved, right? So for all we know is that for all x, there exists a y such that y is cheese and x loves y. And finally, all cheese is loved by someone or other. Okay, that just seems to be a slightly different relation. All cheese is loved by someone or other. Well, now we do have the arrow, right? For all x, there exists a y such that if x is cheese, then y loves x. And here we have an alternative formulation, which is a little bit more intuitive. For all x, if x is cheese, then there exists a y such that y loves x. Okay, so again, you should really take the time to make sure you understand these formulas. I'm not really expecting you right this week to be able to easily write them all out, but to see that they are accurate interpretations of the English sentences is extremely important. So we've already noted that there's no upper limit at all to the number of quantifiers or variables we can use. So here's an example. We're not going to do a bunch of these, but here's an example that requires 3 quantifiers. Dogs are nicer than cats, but cats are nicer than piranhas. How can we say that? Well, we introduce 3 quantifiers, right? 1 for cats, 1 for dogs, and 1 for piranhas. And so what this says is for all x, and for all y, and for all z, if x is a dog, and y is a cat, and z is a piranha, then x is nicer than y, and y is nicer than z. So there's just a little bookkeeping here. We have to know that the x in this case is a dog, that the y is a cat, and the z is a piranha. At the beginning of the lecture, I gave you this massive proposition, and we didn't try to understand it or interpret it, but now let's see if we can. Right? What we'll do sometimes, later on, we'll actually be doing this as an exercise, is that we'll just adopt a particular interpretation. So suppose that P is planet, and M means moon of, and S equals star, and O means orbits, a relation that means orbits, like a planet orbiting a star or a moon orbiting a planet. If we give this interpretation, what would this sentence mean? Well, it would say for all x, for all y, there exists a z, such that if x is a planet and y is the moon of x, then Z is a star, and X orbits Z, and Y orbits X. Okay? So, in other words, if any planet has a moon, then the moon orbits the planet, and the planet orbits the star. So that actually turns out to be true. And we're not interested in truth here. We're just trying to understand the meaning of sentences, but it just so happens that one's true. Okay, finally, just return to this idea of pronouns that tend to be used to indicate people. I noted earlier that that sometimes we'll just take a word like everyone or everybody or someone and just simplify it and act as if it means everything. But usually in English, we don't mean everything. We usually mean these things to refer specifically to people. So sometimes we'll just ignore this, but there'll be other times when we want to really be explicit. So earlier we translated everyone loves cheese as everything loves cheese, but that's a bit awkward, right? Because that means that rocks love cheese, that trees love cheese. It's probably not what people mean when they say that. So what would be a better translation of this? Well, we would just include the specification that this refers to a person. So we would say for all X and for all Y, if X is a person and Y is cheese, then X loves Y. Okay, so it just complicates our statement a little bit more, but it also makes it a little bit more accurate. All right, so we'll go ahead and do some study questions now. Now, these aren't all easy by any means, and so what I want you to do here is try hard to get it right, but don't get too stressed out. If you can't, just make sure that you spend the time to be sure you understand why the particular interpretation I give as the correct one actually is correct. All right?